Okay, guys, so today we are going to work on solving equations from word problems. So these are just going to be 2-step and 1-step equations. And we are going to get some word problems and work through this together. And then in the live on Monday, I'll also be going through some examples for you. But the first thing I want to go over is just some simple vocab. And obviously, this list is not 100% inclusive, but these are just some of the common things you're going to see. So when you see the words some, added to, more than, increased by, you should be thinking addition. Things like difference, less than, decreased by. I'm also going to say you'll see gave away a lot, or like gave his friends or something like that. That is subtraction as well. Along with anything, if you see the word withdraw, that is also subtraction. So basically, anything where the main person the problem is about is losing something, that is going to be subtraction. So multiplication, you'll see product. Anytime they say, it's twice what the original was or something like that. Or if it says, he borrowed money and gave back 2 times more than he was borrowed, you're going to have multiplication somewhere. And then division, if you see the word quotient or divided by, a lot of the times, if you see split equally, if you see the word split, broken into, anytime they're telling you to work with equal pieces, you're going to really be seeing division as well. So now we're going to work through an example problem. So this one says John had some candies. He gave 5 to his friend, and now he has 18. How many did he initially have? So I'm going to underline everything that I think is important. So typically I read the problem first and then go back and start to underline the second time. So some, that just tells me that I don't know how many he started with. And so he gave 5. So gave, I'm going to go ahead and write a -5 above that, because I know that I'm going to have a -5 somewhere. And then it says that he ends, or he now has, which means at the end of giving everything away, he has 18 candies. And then I'm going to actually highlight that last question where it says, how many candies did John initially have? Because that's ultimately what I'm trying to figure out. So where it says to define a variable down here, that's basically what I did by highlighting that last part of the question. So here X is going to represent the number that he started with, because that's what we don't know, right? That's why it's asking us to find that, because we don't know that. So when I write my equation, I'm always going to start with whatever we end with. So up here, now he has 18 candies. That's what we ended with. So I'm going to write an 18. That's what my equation is going to be equal to, because that's what I ultimately had at the end. So then I'm going to go ahead and write X, because I don't see anything that indicates multiplication, which means I'm not going to have a coefficient. And the only other thing I know is that I gave away 5, or he gave away 5. So I've got -5. So I know the number that he initially had, -5, left me with 18. So now I'm just going to solve that equation. And that is going to give me that X is equal to 23. So John initially had 23 candies. So I want you guys to get in the habit of writing your answers in sentences. So when we do return to in-person class, I will expect sentence answers when you have word problems. Probably not on the Google Forms, though. So we'll go to our next one. Alex borrowed some money from Jose. After 3 years, Alex returned 2 times the amount of money borrowed to Jose. If the amount he returned is $226, how much did he borrow from Jose? So here you've got some stuff that's meant to trip you up. So you've got that after 3 years, but when we think about it, that's not really adding anything to the problem. So I'm going to scratch it out, because I don't want that 3 years or that number 3 to get in my way. So he returned 2 times the money borrowed. Times, remember that's a multiplication word. So I'm going to have multiplication somewhere. And I know that ultimately at the end of everything, he returned $226. So I know that at the end of my equation, it's going to be equal to 226. And remember, I'm going to go ahead and highlight right here. How much money did he borrow from Jose? That's what I don't know. So when I go to define my variable, X is going to be equal to the amount of money borrowed. So when I write my equation, like I said, I know I end with 226. So that's what I'm setting my equation equal to. And I know that that the money he gave back, that $226, is equal to 2 times that initial amount. So my equation is going to be 2x. And then I'm going to come down here and solve it. And I'm going to see that Alex originally borrowed $113. So for this one, it tells us that a car is traveling at 915 miles, that it traveled 915 miles at an average rate of 61 miles per hour. And it wants us to figure out how long the car was traveling. So I'm looking for time. So I'm going to just go ahead and start with the 915 miles. And to do this problem, it's kind of more confusing to set up an equation. So normally what you would do is you would be given the equation that distance equals speed times time. But here we have to rearrange that, and we are going to be given the equation time is equal to distance over speed. So all we're doing is rearranging an equation that we should already know, and you'll see more of what that looks like. Actually, I'm just going to work that one out in the live tomorrow. So we're going to just skip this one real quick. Okay, and we're going to come down to the area of a rectangle. So the area of a rectangle is 20 square inches, and the length is 4.5 inches. What is the width? So that's asking you. So the first thing we need to be thinking of is our formula for the area of a rectangle, which is area equals length times width. So sometimes you will luck into problems that have equations that are already set up to be with them, really, which is why I want to like rework that top one for you, because when I worked it out, I did not do that. So here on the area question, I have an area already, and it's equal to 20, and I already have a length as well, which is equal to 4.5. So I'm going to go ahead and plug those numbers in, and I end up getting 20 is equal to 4.5 times W, and then I can solve that as a one-step equation. So I divide on both sides, and I'm going to get 4.4 repeating is inches is equal to my width. Okay. And in this third problem, so Manuel ran the 200-meter race in 22.8 seconds, which is 1.9 faster than Mikkel. What was Mikkel's time? So again, I'm going to cross out 200-meter race because that really has nothing to do with the problem. And instead, I'm going to underline 2.28 seconds. And that tells me that 2.28 is 1.9 more, less than what Mikkel did. So I know that I ended with 22.8, and that is equal to something minus 1.9. So here I'm going to use X to represent Mikkel's time, because that's what I don't know, right? And since it's faster, that means Mikkel ran slower than Manuel. So I know that the answer I get for X should be bigger than 22.8. And this is where I made a mistake, which is why I'm fast forwarding through it. So here, I know that X is Mikkel's time. And the reason I'm subtracting 1.9 is because since Manuel ran faster, so Manuel over here was faster than Mikkel, I know that this X has to be bigger than 22.8. So if I were to do X plus 1.9 over here, I would end up subtracting 1.9 from both sides, and I would get a smaller number for X. So that's not going to work. And because I know that, like I said, X needs to be bigger than 22.8, so it doesn't make sense to be adding time on there. So I'm going to go ahead and solve this. And I'm going to get 24.7 equals X. So Mikkel's time was 24.7 seconds. So this problem right here, Melanie saves $20 every month in her savings account. We're going to underline that 20 every month. And she withdrew 60 one time. She now has $280 in her account. And it's asking us to write and solve an equation to determine how many months she has been saving. So normally this, like how many, or things like that, that's where you're going to be finding what your X is. So since we don't know how many months, X is going to equal the number of months. So normally whatever it's asking you to solve for, that is what X is going to equal. So when we write our equation, we know that she ends with $280, so that's what we're going to set our equation to, because that's our stopping point. So now I know that X is the number of months. So let's go up into the problem, and we see that in addition to saving saving so much money per month, we know that each month also is attached to this $20. So every single month she deposited $20 in that bank account, which means the 20 and the X are going to go together. So our equation is going to be 20x to represent the fact that she put $20 in the account every month, and x is the number of months, minus the $60 because she withdrew $60 one time, and withdrew means she took that out of her account. Okay, so the $20 every month, so that's why it's attached to the x, because x is the number of months, minus 60 because she withdrew $60. So I'm going to go ahead and solve this just like a normal two-step equation. So she saved for 17 months. So down here, a group of 4 people ate dinner at a restaurant. They divided the bill equally, and each person left a $2 tip. They each paid $14. Write and solve an equation to determine the amount of the total bill. So I won't lie to you guys. Like, I had kind of not a hard time solving this, but it took me a minute because this is one of the ones that you kind of really have to think about. So there's a couple things that come into play here. So as far as defining the variable, we have to remember that the variable is going to be what we don't know. And what we don't know here is the total amount of the bill. So that is actually what our variable is going to end up being. So X is going to end up being your total bill. Now, normally I would say the total bill is what your equation needs to be set equal to. But in this case, it's a little different. So instead of the total bill, our equation is going to be equal to the total amount that each person paid. So we're going to set our equation equal to $14 because each person in total paid $14. Now, when we think about the total bill, we're going to come up here and we see that they divided the bill. So I'm going to go ahead and put X on top of a fraction because it straight told me they divided the total bill. And it says they divided it equally. Well, there are 4 people. So if they divided it equally between 4 people, that means they put the total bill over 4. And then remember, each person left a $2 tip. So when we think about it, each person paid $14, and that $14 included 1/4 of the bill and a $2 tip. And that's where we find how we make our equation. Okay, now we're going to solve this by subtracting our constant from both sides, and we'll get 12 is equal to X over 4. So just remember, the total that each person paid was $14, which was comprised or made up of 1/4 of the bill and a $2 tip. So now we've gotten rid of the $2 tip, and we're just trying to figure out how much so we've gotten rid of the $2 tip, and we know that $12 is equal to 1/4 of the bill. So now what we're going to do is take each side and multiply it by 4. So instead of just 1/4 of the bill, we're now going to have X, which is the total bill, and we're going to see that that's equal to $48. So the bill is equal to $48. All right, guys. So we are going to be going through a lot more examples this week. I know these are confusing, so I promise you we will continue to work through example problems. I'm going to be doing some in the live on Monday and Tuesday, and then I'll be doing a bunch in the live on Wednesday and Thursday. So I highly encourage you to come to that. Your solving equations kind of like final, when we're going to be completely done with equations for a while, that will be dropping this week. And then that is what you've got to look forward to. And there are not any word problems on that. So don't stress about that. Okay. So, as always, if you need any help with anything or have any questions, please reach out to me. I am here to help you. But other than that, have a great rest of your week, guys. Thanks.